Okay, so I asked you to do numbers 4, 5, and 6 on this sheet. Okay, so maybe a few more kinematics questions. So number 4 says a football is kicked vertically upward from the ground, and a student gazing out the window sees it move upward past her. Okay, so this is one of those up and down ones. So the football's going up, and there's two sections below the window. And this time, instead of the window as the other section, it's like above the window or maybe even above the student, because it doesn't say anything actually about the window itself, just that the student in the window sees it. So when the student in the window sees it, at this imaginary line here, it's going 5 meters per second up. So at the beginning of the section above the above window, below its VF then is 5 meters per second, still up. It's being kicked with some velocity that we don't know, but it definitely has one. A is 9.81 meters per second squared down. And in the question it says the window is 12 meters above the ground. So the delta D in this section is 12 meters up. Now in the upper section, A is still 9.81 meters per second squared down. And the question says, how high does it go above the ground? Well, it's going to go up until eventually somewhere above the window, it's going to stop. And the question wants to know how high is that, delta D. So in part A, we can actually solve it in the first section, right? We have our VF, our VI, and our A. We can get delta D by using VF squared is equal to VI squared plus 2A delta D. VF is 0, and you're going to rearrange for delta D. So it'll be VF squared minus VI squared is equal to, and to get the delta D alone, divide by the 2A. And like I said, the VF goes to 0. So it'll be delta D is equal to negative VI squared over 2A. So negative brackets 5 meters per second, and that gets squared, divided by 2 times negative 9.81 meters per second squared. Okay? And you're going to solve for your delta D here. Wondering where my calculator is. All right, so 25 negative divided by 19.62 should give you 1.2742 meters. Okay, that's the height of the second part. It says, so this is D2. A says, how far did it go above the ground? You would then need to add that to your 12 meters to get 13.2742 meters as your final answer in A. B says, how long is it in the air? So we don't know the time for either section, so we could find our VI down here, because look at what you're given. You can find your VI if you have A, delta D, and VF. So you can do VF squared equals VI squared plus 2A delta D. And we can solve for VI. So VI squared will equal VF squared minus 2A delta D. So this is part B. So VI squared equals 5 meters per second squared minus 2 times negative 9.81 meters per second squared times positive 12 meters. This negative and this negative are going to end up making positive, so it's going to be 25 plus, what is that, 235. Add them together, so you get about 260.44. Take the square root, 16.14 meters per second up is the VI, which they don't actually ask you to find, but you need to find it to find the time. Okay, so you now have your VI. You could actually find the time of the whole thing in one step by just doing A equals VF minus VI over delta T, and using this that you just found as your VI down here and your VF as 0. So delta T total would equal VF minus VI over A. So this goes to 0, so that negative 16.14 meters per second that you still have in your calculator, divided by negative 9.81 meters per second squared. And you should get a T total of something like 3.29 seconds. Now you could have also done it in parts. You could have found the time for this section and the time for this section and added it together. You should get exactly the same answer. But doing it all in one step is just a little bit quicker, which is why I did it that way. Okay, so that's number 4. Number 5 says, a physics teacher performing an outdoor experiment suddenly falls from rest off a high cliff and simultaneously shouts, "Help!" When she has fallen 3 seconds, she hears the echo of her shout from the valley floor below. The speed of sound is 340 meters per second. How tall is the cliff? So 2 parts, teacher, sound. Falls from rest, VI is 0. A is 9.81 meters per second squared. Sound, VAV. Don't worry, this is not a quadratic. 340 meters per second. And so it's so if you imagine what's happening, here's the cliff, here's the teacher. Okay? She falls, and she shouts at exactly the same time, "Help!" And so as she shouts it, it goes down, and it comes back up so that after 3 seconds, when she's here, she hears her own echo, because we're assuming she hasn't died of a heart attack when she fell off the cliff. So the time that passed for the teacher is 3 seconds. And the time that passed for the sound is 3 seconds. And so with those 2 times, we can find out how far each traveled in that time. So delta D of the teacher is VI delta T plus 1/2 A delta T squared. The VI goes to 0. So delta D of the teacher is equal to 1/2 9.81 meters per second squared times 3 seconds, which gets squared. So the half of 3 seconds squared is 9. Half of 9 is 4.5. Multiplied by 9.81, you get 44.145 meters. So she has fallen 4 times the height of the school, more than 4.5 times the height of the school. Okay? Meanwhile, the sound has traveled some distance, which we can find. VAV is equal to delta D of the sound over delta T. So delta D of the sound equals VAV delta T. Delta D of the sound equals 340 meters per second times 3 seconds. 1020, I believe. Well, no, it was only if I knew where to put the decimal. I think it's 1020, yeah. 0, yeah, it is. Okay? So the first part of the question wants to know how tall the cliff is. Well, we know this section is 44.145 meters. And we know all the way down and up to here is 1,020 meters. So we could add them together, and if we add them together, we don't get D total. We get 2 times D total, right down and up. So if you add 44.145 meters to 1020 meters, you get 2 times the total height of the cliff, which would be 1064.145. So the height of the cliff, you're just going to divide by 2. So 532.0725 is the delta D total. Okay? And it's because she falls part way, the sound goes all the way down and comes back up and meets her. So when you put it together, you get a full up and down, which you then have to divide in half. So that's part A. Part B wants to know how fast will she be moving just before she strikes the ground. So you could do VF squared is equal to VI squared plus 2A delta D. So VF squared is equal to 2 times 9.81 meters per second squared times the 500 and whatever we just found. I'm going to run out of time. VF is equal to